Hey guys, this video we are going to continue with example 3, double I. So I'm gonna do a line down here. I have my normal stylus back, so I should be writing much better than yesterday. Okay, hopefully. Here we go. Make sure when you guys are doing your homework, make sure you read directions, okay? Find the following. That means we're doing A, B, C, and D. In addition, we need to state the domain for each composite, not one domain, but all 4 composites would need to have its own domain. So the first thing we're going to do is letter A. Letter A says F composed with G, which by definition is F of G. Your input is an X, F of G of X. Well, you know what G is. G is this function right here. So we're going to go do F of 2 divided by X plus 1. Now, yesterday, to state the domain, we need to state the domain at the initial. So the domain at the initial, which is, let me just do a highlighting piece right here. Here's your input, initial answer. So the domain for this is going to be all real numbers. X can never ever be -1 because it has a fraction. Because in class today, a lot of you ask, hey, well, is the domain always all real? And the answer is no, the domain will not always be all real, okay? It depends on what function you are provided with. So now I'm just going to look at f. Here's your f function, and I'm going to plug in 2 divided by x for every time I see an x variable. So 3 divided by, I see an x variable. I'm going to write down the -5 first. What an x variable right here tells me that I'm going to put in this new input, 2 over x plus 1. Well, this next step, it's actually pretty difficult for some of us because when you're subtracting, make sure you find the common denominator, okay? So from here, the numerator will stay as 3. The denominator, the common denominator, I'm just going to write all the steps out so you can see where this is coming from. -5 over 1, because you are subtracting fractions. So make sure you're going to have 2 fractions here. And again, we're going to write 3 numerator down. 2 over common denominator is going to be an x plus 1. So this denominator is now x plus 1. What you multiply to the bottom, you multiply to the top. This one gets x plus 1 as well. So now we're going to slowly work this out. This is 3 divided by 2 over x plus 1. This has not changed at all. Minus, I'm going to do 5 times x is 5x. 5 times 1 is +5. Okay, all over x plus 1. Now that we have the same denominator for the denominator, oops, this is supposed to be a 3. This is 3. So 3 divided by, we haven't done anything with the numerator. So I'm going to combine these two over here. Okay, see this? So now the denominator is the same, x plus 1 on the top. I'm going to cautiously write 2 minus quantity, 5x plus 5, okay? And the reason I'm going to need to write that as a quantity because I need to distribute that negative sign throughout. So now we have 3 on the numerator. You can write 3 divided by with a dash bar, or you can write 3 divided by using this. Let me show you. 3 divided by this, okay? That's exactly the same. Now I'm going to distribute. The denominator stays as x plus 1. 2 minus 5x minus 5, okay? Then from here, I just need to make this simplify some more. 3 divided by a 2 and a -5 is I'm gonna bring down my -5x minus 3 all over an LCD of x plus 1, okay? Now from here, I'm just going to make a 3 into a fraction of over 1 and continue to simplify. 3 over 1 times its reciprocal, x plus 1 over -5x minus 3. Then from here, we have 3 times the quantity of x plus 1 all over -5x minus 3. Your book tends to not like a negative under the denominator. So what you can do is you can factor out a -1 down here and have it as a +5x plus 3, and that's okay too. And you can bring the negative up on the top. So 3, -3 now, x plus 1 all over +5x plus 3. And this is the answer to the composite, okay? As you can tell, there's a lot of work involved. Now that I have my answer, I'm going to box that up. Now check out this right here. See how this domain of this function, okay, x can never ever be negative. You take this and you set it equals to 0. So 5x plus 3 equals to 0. 5x equals negative 3. X equals to negative 3/5. So x can never equal to negative 3/5. But you also need to bring this piece down, which I'm going to highlight right now. See this right here? Woo! So I'm going to come and bring that in here, which I'm going to write with a blue or green pen to match. So x can't be negative 1 as well. So I'm going to box that up and I'm going to pause. I will come back. All right, guys. We are now going to continue with letter B. Let me see what letter B says. Letter B says we are about to do G composed with F. G composed with F. All right. So by definition, this is G of f of x. Okay, so what I will do first is enter in f of x, and let me see what f of x was. F of x was 3 divided by x minus 5. So G of 3 divided by x minus 5. Keep in mind that later we would need to find the domain. So the best spot right now is to find the domain always of your input. Okay, then you would need to add it with the domain of the output, and that will be the domain for the entire composite. Okay, so now let's go back and check out what G function was. G was this one, okay? G was that one. So 2 divided by x plus 1. So 2 divided by x plus 1. So I'm going to write the plus 1 first. Well, that x plus 1 get replaced with the new input, which is 3 divided by x minus 5. So from here, we will find a common denominator. The numerator of 2 stays exactly the way it is. 3 over x minus 5 will stay exactly where it is. I'm going to convert 1 into a denominator of x minus 5. What I multiply to the denominator, I need to multiply to the numerator. Okay, oops, that should be a minus. So let me erase, and that should have been a minus. And let me fix that 5. Okay. So with that, now let's do our next step. 2 divided by, and yes, you can write division this way. I'm going to do the denominator. LCD are now exactly the same at x minus 5. So we are rewriting one LCD. On the top, you have 3 plus x minus 5. So we're going to keep on simplifying this problem out. 2 divided by 3 minus 5 is negative 2. So I have x minus 2 all over x minus 5. I'm going to make the 2 into a fraction so I can multiply by its reciprocal. So this is now moving on up. Oops, I should add another parenthesis here. So now this should be a 2 over 1 times its reciprocal, x minus 5, all over x minus 2. And from here, you can do a couple of things. You can write 2 times x minus 5 all over x minus 2. That could be your final answer. Okay, you can totally box that up. Or you could distribute your 2. So 2x minus 10 all over x minus 2. That could also be your answer as well. It doesn't really matter if you distribute or factor. Either way, it's the simplest form that it can be. Now, so check this out. This right here, this domain cannot be, x can never ever be. Oops, sorry, this is supposed to be a 2 in the bottom. Okay, so that's a 2. Okay, so this domain is x can never ever be 2. So you have to put the 2 domains together. And what am I talking about? What 2 domains is she talking about? This domain at the initial and this domain at the end. So when you write your final domain of the composite, you have to combine both. This one, x can never ever be 2 or 5. And this is what you need to box, okay? Both of the exclusions have to be there. All right, now that we are done with, I'm gonna make this line. I'm looking for C. What is C asking? C is asking us to do the composite of f of f. Okay, so Here we go. I'm gonna try to squeeze in here just because I know I'm gonna run out of space. So here's C. So by definition, f of f is f of x, okay? So in my f function, let's see what f was. F was 3 divided by x minus 5. So 3 divided by x minus 5. I am composing this to myself. In this case, myself is the f function. So I have 3 divided by, there's only one x location, okay? So that x location gets this input, which is 3 divided by x minus 5. Then from here, you will find the common denominator of the bottom. So 3 divided by 3 over x minus 5 minus 5 over 1 is really what you want to think about that. Well, LCD is going to be x minus 5. So I'm going to write this way. 3 over x minus 5 minus, now this gets an x minus 5 here. What I multiply to the bottom, I will multiply to the top and slowly distribute this out and carefully. Because as you know by now, I can't divide and I can't multiply. Hopefully I can add and subtract, okay? So this gets a 3. We're not really doing anything with this piece, 3 over x minus 5. This, I'm going to carry the x minus 5 on the bottom. I'm just going to slowly distribute my 5x. 5 times a negative 5 is a negative 25, okay? Now keep in mind, I haven't really distributed this negative sign yet, okay? I'm going to do it right now. So 3 divided by, now I'm going to distribute this negative sign. So 3 maintains in the front. This negative sign is now going to be a negative 5x. Negative times a negative is going to be a positive 25, okay? So that's how I'm doing that piece. You can do that piece multiple ways, but that's just one way of me doing it. Then from here, we can go a little bit further. 3 divided by, I'm going to combine like terms. So 3 and 25, that's a 28. Okay, so negative 5x plus 28 all over x minus 5. Then from here, we will now multiply by its reciprocal, x minus 5 over negative 5x plus 28. Then from here, you can leave 3 times x minus 5 as undistributed, or you can multiply it in. It doesn't really matter. Now, your book normally doesn't like this negative on the bottom, so what you will need to do sometimes, if you want to make sure the answer is right or match up with the book, is take out that negative sign. So now you have a positive 5x, take away 28. So you can leave the 3 on the top with a negative now, okay? So all you're doing is multiplying this bottom by a negative 1 and this top by a negative 1 to cancel out this negative sign. So now on the top you have a negative 3 times the quantity of x minus 5. On the bottom is now just nicely positive 5x, minus 28. So let me just change it to a minus. Actually, it is a positive, isn't it? Let me just, okay. So this is now 28. So I'm sorry, it's a minus, okay? Because these two negatives cancel each other out. Okay, so this is my final answer. Now, did I get too excited and forget to state the domain at the beginning? Let's go back and state the domain. Here's your initial. So this domain is going to be all real numbers, not including to 5. This end domain is going to be 5x minus 28 equals 0. 5x equals 28, divide both sides by 5. So 28 divided by 5. So this domain is x cannot be 28 over 5. So let's put together for our final domain, okay? So this domain for this composite class is going to be x can never ever be 28 over 5 and 5. So these are the two values we are excluding. There is a lot of basic math involved for these type of problems. So if you are showing me all of your work, I will give you most credit if the pre-calculus skills are correct. Now, if you're missing like a negative or a positive, or you're like me and you can't divide, 6 divided by 3 is 3, I will give you most credit, okay? So make sure the work is shown, okay? We are now on the last problem, G composed with G, which I'm going to be out of space. So what I will do is I'm just going to do it over here. If you have space, then feel free to do it on the bottom. So D. G composed with G, which is by definition G, it's now its own input. So let's see what G was. G was 2 divided by x plus 1. So G was 2 divided by x plus 1. So keep in mind, this is where we go and find the domain, okay? So the domain is all real numbers where x can never ever be -1. We will have to use that later. All right, so now we're going to enter in. We have one input, so I'm going to give that input the 2 divided by x plus 1. And from here, we will find the common denominator. I'm going to write 2, divide this symbol. So 2 over x plus 1. This is going to have a denominator of x plus 1 as well. What I multiply to the top, I multiply to the bottom. So from here, it's 2 divided by, the denominator are exactly the same, so I can combine the numerator. So I numerator have 2 plus x plus 1. And from here, we will go a little bit further, 2 divided by. So 2 plus 1 is 3, so x plus 3 all over x plus 1. And from here, we will multiply by its reciprocal and making the 2 into a fraction. So this is the reciprocal of x plus 1. So now you have 2 times the quantity of x plus 1 all over x plus 3. You can leave this as your answer, or you can distribute your 2 out. It doesn't really matter. But keep in mind that this cannot be -3. So your domain for the final, okay, it's going to be x can never ever be -3 or -1. Okay. So keep in mind that when you're looking for the domain, make sure you pay attention to the initial, which is the input function, and the final answer, which is the output of the composite, okay? Okay, so this is the end of our video notes. We will see you in class.